drunk and all of our thumbs went up in the air. Sung it in the wind and sung to the thunder, rolling over and over we die. We're getting on fire, we're raising up higher. The bottle is up, we're over the top. It's time to get...
Assalamualaikum and hi. My name is Nurul Hanan Afifah binti Zamakhsyari. My student ID 2022737003. The chemistry laboratory may be an excellent setting for instilling good work practices and teaching safety, all while learning vital science skills. Although the chemistry laboratory provides a pleasant, safe, and enjoyable learning environment, scientific programs seem to have potential risks. Each of these groups, which are teachers and students, must perform a major role in the creation and implementation of a chemistry laboratory learning program. So, as a result, it is important for everyone to be aware of and understand their respective responsibilities as well as what to conduct when in the laboratory. And of course, students must be taught about what might go wrong, how to avoid such situations, and what to do in the event of an emergency. Lesson outcomes for this presentation are to describe about what teacher and student responsibilities, ensuring the chemistry laboratory is safe, learn about chemical health hazards, how to label the chemical reagents, how to store the chemicals, and how to handle the hazardous chemicals. What is the teacher's responsibilities during laboratory? Okay, the most essential initial step is a teacher must become familiar with each experiment protocol, which includes how to operate all the equipment, the identification and hazards of all chemicals used, and protocols for preventing and recovering from accidents. So now, I will tell you about the equipment and tools that are commonly found in laboratories. Firstly, we have safety equipment or PPE, which include goggles, latex gloves, and lab coat. Then we also have Bunsen burner, test tube, wash bottle, beaker, and more. So, for your better understanding about lab tools and equipment in chemistry laboratory and their own functions, let's watch this video together.
Chemistry tools and equipment. Before we begin with the principles of chemistry, let us review what kind of glassware and equipment we use to study this broad subject. Safety gear. One of the major things we often ignore is wearing a safety gear. This includes goggles, a pair of latex gloves, and a lab coat. This not only makes you look cool and makes you feel like a responsible scientist, but also protects you from all kinds of chemicals you may be coming into contact with, knowingly and unknowingly. Electronic balance, used for measuring mass of a substance or chemical, usually consists of a pan on which you can place the substance you want to measure. This generates current proportional to the displacement of the pan due to the pull of gravity, which then translates into the displayed reading. The electronic balance is a simple, yet one of the most important equipment that should be present in any laboratory. Ring stand, used as support to clamp laboratory glassware and other equipment in place, so it does not fall down or come apart. Ring clamp, used with a ring stand to hold glassware such as a beaker or a funnel. Wire gauze, may have a fiberglass or ceramic center, used to support a container such as a beaker on a ring stand while it is being heated. Bunsen burner, be careful not to put flammable materials like a cloth or chemicals like aromatic compounds such as petrol anywhere near it, or this may erupt a fire. Beaker. A beaker is glass apparatus used to hold, mix and heat liquids. Beaker tongs. Metallic and looks like a scissors older sibling. Beaker tongs is used to handle beakers. Crucible. A ceramic pot used for holding chemicals during heating at very high temperatures. Clay triangle. A metallic triangle used to support a crucible during heating. Crucible tongs, used to hold crucibles. Evaporating dish, a wide ceramic dish used to heat liquids for evaporation. Utility clamp, a metallic clamp used to secure glassware to a ring stand. Burette, a long glass graduated tube with a tap around it. A burette is used for dispensing an accurate volume of a liquid and measuring its discharge. Conical flask, also known as the Erlenmeyer flask, is a glassware that has a narrow neck that expands towards its base. It is used to hold and mix chemicals. The small neck is to facilitate mixing without spilling. Test tube, a glass tube with a round base used to hold and mix liquids. Needs a steel rack or a clamp to hold it. Pipette bulb, a round rubber bulb used to draw liquids into a pipe. Forceps, used to pick up or hold small objects. Mortar and pestle, used to crush and grind materials. You may have seen something similar in your kitchen. Scoopula, used to transfer solids. Looks similar to a spoon. Stirring rod, used for stirring and mixing and is usually made of glass. Funnel, it is used to transfer liquids or fine-grained materials into containers with small openings. Also used for filtration. Volumetric flask, a volumetric flask is a round flask with a long neck and a flat bottom. It is used to prepare solutions to an accurate volume. There is a small line on the neck that indicates how far to fill the bottle. They come with special caps to prevent contamination and leaks. Volumetric pipette. This comprises of a graduated glass tube that is used to measure an exact volume of liquid. Be sure to use pipetting aids for precision mixing. Graduated cylinder, used to measure a precise volume of a liquid. Wash bottle, used to rinse pieces of glassware and to add small quantities of water. Do you know where some of these tools originated from? Find out in our video titled A Brief History of Chemistry.
Other than the equipment shown in the video, there are also several equipment that require specific technique or steps to use it so that no danger occurs. Okay, first is compressed gas cylinders. Compressed gases may be dangerous since each cylinder contains a huge amount of energy and may be very flammable and poisonous. So, as a result, we must understand how to use it properly. The first step is always handle cylinders with care and avoid heavy throwing or bumping. And if the gas cylinder is discovered to be physically damaged, notify the supplier immediately. Next, the cylinder valve should be examined before use. This step is necessary so that we can determine whether the valve is safe to use or not, and most importantly, the valve can be opened easily. Third, when in use, gas cylinders should be placed upright in stands, wall brackets, or trolleys. Next, stiff valves should be handled with caution. If possible, use the conventional key to open the valve gently by hand pressure. Okay, in this step, avoid using hammers or high leverage and avoid lubricating any valves or fittings, especially regarding to oxygen cylinders. However, if the cylinder with stiff valves still cannot be handled, it should be returned to the supplier right away. The fifth step is do not handle oxygen cylinders, valves or any fittings with greasy hands, gloves or rags. But why? Okay, it is because so that oxidation of the grease under pressure can be avoided and no explosion occurs. The last step is always utilize gas cylinders in a well-ventilated place to avoid asphyxia. What is asphyxia? Okay, asphyxia is a condition when the body does not receive enough oxygen and then affects our regular breathing that may cause unconsciousness and may even result in death. Next, I am going to talk about Bunsen burner. A Bunsen burner is a type of gas burner that is often used in laboratory experiments as a heat source. However, it is dangerous if not utilized appropriately. So, when conducting experiments, please ensure that all air conditioners are turned off and exhaust fans are turned on, and all windows should be left open to provide for good ventilation in the laboratory. Now, let's watch the video on how to use the Bunsen burner safely.
The Bunsen burner is a great way of heating up substances in a controlled way, but it must be used with care. A handy way of remembering how to light a Bunsen burner safely is set a light. Let's see what this means. S is for safety, which always comes first. Make sure you're wearing a lab coat and safety glasses. Tie back long hair and clear your bench of anything that's flammable, meaning that it could catch on fire. E is for edge. Place the burner on a heat-proof mat a safe distance from the edge of the bench. T is for tube. Check that the rubber tube is free of cracks. Connect the tube firmly to the gas tap. Make sure the tap is in the off position. Remember, the off position makes an L shape. A is for air hole. The air hole is located at the bottom of the barrel, near the base. It can be opened or closed by turning a metal ring called the collar. This controls the amount of air and oxygen that mixes with the gas. The more oxygen, the hotter the flame. Always make sure that the air hole is closed before lighting the burner. Okay, you're ready to light the match and hold it above the barrel. Finally, you can turn on the gas. It's important to light the match first to avoid releasing dangerous gas into the air. You should always follow these 6 steps when lighting a Bunsen burner. Now you've successfully lit the Bunsen burner, you should begin with a bright yellow flame. This is called the safety flame because it's easy to see and isn't as hot as the full flame. To get a hotter flame, we need to mix in more air. To do this, turn the collar to open the air hole. You will now have a blue flame with a bright blue inner core. The hottest part of the blue flame is here, at the tip of the cone. There are 3 more safety rules for using the Bunsen burner while it's lit. If you need to move the burner, hold it by the base. Don't touch it any higher than the collar. Never leave a lit Bunsen burner unattended. And if anything goes wrong, turn off the gas tap immediately. Okay, so you've finished your experiment. Before turning off the Bunsen burner, close the air hole first to return to the safety flame. Now you can turn off the tap and blow out any small flame that remains. Disconnect the hose and leave the Bunsen burner to cool before packing it away.
Apart from need to know about the equipment in the laboratory and how to use it, teachers also need to know about the types of chemical hazards that will be used for the experiments so that they know how to manage the chemicals correctly. Here, I include some chemicals with their types of hazard. Okay, examples of chemicals that are in the toxic class are mercury, chlorine, and bromine. These chemicals can cause serious, acute, or chronic health risk and even death if it was inhaled, ingested, or absorbed through the skin. Next, flammable chemicals. This type of chemical may explode if mixed with oxygen or air. The examples are hydrogen sulfide, carbon monoxide, and hydrocarbon gases. And the third type of chemical hazard is corrosive, which may cause serious injuries on prolonged contact with skin. Examples are hydrochloric acid, sulfuric acid, and sodium hydroxide. As a teacher, we also need to know about how to prevent and treat an injury or accident that occurs in the laboratory so that worse things can be avoided. For example, a teacher was conducting a lab class at school. Suddenly, one of his students is holding a very hot glass container and causing his hands scald. So, what action should he take to treat his injured student? Okay, first thing first, place the affected area under slowly running cold water until the pain fades. Second, remove any watches, rings, belts, shoes or other constricting clothing from the injured area before it starts to swell. But do not remove any clothing adhering to the burn. Third, do not apply lotions, ointments or any other chemicals to the injured area, and do not break blisters or remove any loose skin. Next, cover the affected area with a dry, steel dressing and then secure with bandage. Never use adhesive dressing. And as far as possible, immobilize the affected part to minimize pain. Lastly, for severe burns, medical aid should be sought without delay. As we all know, prevention is better than cure. But how to prevent this accident from happening? Okay, to avoid this accident from occurs, hot objects, hot liquids, Bunsen flame or light matches need to be handled properly. Never use your bare hands to hold or touch the hot surfaces, but use tongs to hold or lift them. Now, let's watch the video about the common lab accidents and how to avoid them. The teachers have known about the equipment used in the laboratory, the types of chemicals to be used, and how to treat and prevent accidents in the laboratory. Now they can create a culture of safety in chemistry laboratory. There are 4 ways to create a safe chemistry laboratory environment. Firstly, upkeep of laboratory and equipment. Second, record keeping. Third, safety and emergency procedures. And fourth, maintenance of chemicals. Number 1, upkeep of laboratory and equipment. Conduct routine checks of safety and first aid equipment as often as the administration requests. On the connected equipment inspection tick, write the inspection date and the inspector's initials. Next, notify the administrators about the hazardous condition. If a hazardous or potentially hazardous condition such as malfunctioning safety equipment or a chemical danger is detected in the laboratory, notify the administration in writing and follow up on the status. And lastly, never utilize damaged equipment. Number 2, record keeping. Keep records of staff safety training and all laboratory incidents for as long as required by the school system. This means do not discard or delete any records related to the laboratory because it is very important to be used as a reference in case of any emergency. Number 3. Safety and emergency procedures. Before beginning any laboratory work, teach students where to find and how to utilize all safety emergency equipment, such as the location and use of switches and cut-off valves for water, gas and electricity in the laboratory, as well as safety and emergency equipment such as safety shower, eye wash, first aid kit, fire blanket, fire extinguishers, and mercury spill kits. Second, assist students in identifying emergency safety protocols to follow, such as giving students with verbal and written safety procedures to follow, and always remind students of the consequences of not adhering to safety regulations. Third, keep a list of emergency phone numbers near the phone to make it easy to dial emergency calls if an accident occurs in the lab. And regularly conduct adequate safety and evacuation drills. Number 4. Maintenance of chemicals. Conduct frequent chemical inventory inspection. It is as well as updating the chemical inventory at least yearly or as required by the administration, and distribute a copy of the chemical inventory to local emergency responders such as firemen. Next, store food and beverages away from chemicals, as food can become contaminated by chemical gas particles in the air and compromising food safety. And after that, understand the chemicals storage, handling, and disposal requirement. If possible, store all chemicals in their original containers. Ensure that all chemicals and reagents are properly labeled. Do not put chemicals on inappropriate place. Properly dispose of certain chemicals. And store disused chemicals in a locked facility with limited access. For disposal information, see their label and the Material Safety Datasheet (MSDS), and always follow relevant chemical disposal rules. What is MSDS? MSDS, or Material Safety Datasheets, is a document that contains information on how to properly handle, store, and dispose of chemical compounds. And MSDS is included together with all chemicals or chemical containing kits. If an MSDS is not included with a chemical, it can be acquired at www.msdsonline.com.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Nur Afika binti Ibrahim Istar, and I'm going to talk about the students' responsibilities and how to ensure the chemistry laboratory is safe. Science is a hands-on laboratory class that required to do many laboratory activities which require the use of hazardous chemicals. However, life-threatening injuries can happen in the laboratory. For that reason, students are responsibility to follow all the rules to help guide them in protecting themselves and others from injury in the laboratory. The following checklist may acquaint students with the conduct expected in the chemistry laboratory. Every student must follow the general laboratory safety rules and guidelines that was provided by the teacher. Firstly, students should read and understand the rules of the safety contract. Students and their guardians will sign this contract to ensure the safety of the students. Secondly, students must know about the emergency procedures and be familiar with what to do in case of an accident occur and whom to report or to contact. It is imperative to know where items like fire extinguishers, emergency showers, eye wash faucets, first aid kit, and fire blankets are stored, and how to use them. Understanding the procedure before starting an experiment is essential for students. Do not conduct experiments without prior training. Follow the instruction provided by the teacher and get help if you are still unsure of a certain procedure. Not only that, students need to study and understanding the chemical pictogram to identify the chemical properties and their potential hazards. All this must be clear to every student handling the chemicals. GHS is a graphical composition that was labeled on the chemical containers to show the hazards of products and the type of hazard present in them. This action will help students to identify the dangers of the chemicals to prevent injuries, illnesses, and fatalities. For example, this is the GHS methanol label. It shows that the liquid are toxic and highly flammable. It will cause damage to eyes by ingestion. Therefore, handling this chemical properly is important to prevent any incidents happening. It is responsible for every student to follow all the safety rules in the lab. Therefore, they need to know personal protection and housekeeping rules and guidelines to minimize the chances of harm befalling them within the work environment. Firstly, it is crucial for students to dress appropriately according to the laboratory dress code. Avoid wearing shorts and short clothes since it will leave your legs vulnerable to chemical spills. Clothes and well-fitting flat shoes are essential to protect toes. Dangling jewelry on the hands, neck, and hair should be removed once enter the lab space. Always use recommend PPE during experiment such as lab coat to protect from splashes, spills, or exposure to chemical agents. Use safety goggles to protect eyes since our eyes are fragile and eye injury can be permanent. Students should also wear gloves to protect skin from hazardous materials. However, exposure can also occur when removing gloves. Hence, follow the picking method shown in this video to remove gloves properly.
Proper removal techniques reduce the likelihood of exposure from contaminated gloves. The beak method of glove removal greatly reduces the likelihood of contaminating hands and wrists during glove removal. This method is designed to remove gloves while avoiding contact between the outer potentially contaminated surface of the gloves and the wearer's skin. Using the fingers on one gloved hand, pinch the base of the opposite glove and pull away from the wrist in a pinch and pull fashion. Slide the middle finger to scoop the cuff of the glove. Pull the glove inside out over all of the fingers and thumb to form a beak. Use the beak to pinch the opposite glove at the base and pull the cuff. Roll the glove inside out and off the hand. With the ungloved hand, use the index finger to pull the beaked glove off at the base and dispose into a waste container.
Not only that, students should practice good hygiene. Wash hands with soap and water after handling any hazardous materials to make sure that you don't carry any traces of chemicals with you. This is important if you plan to eat afterwards to avoid transfer of chemicals to the food. For a more efficient workspace, ensure that no items block the path and aisles to reduce tripping hazards. It is crucial in case of an emergency and people need to evacuate fast. Remove unnecessary items from the bench to avoid cramming workspaces. This will help to reduce the chances of knocking over items, causing breakage and spillage. Students should avoid any unauthorized activities in chemistry laboratory. They should never engage in horseplay or play tricks. These manners are strictly forbidden in any laboratory since it was very dangerous. Students will be barred from participating in future lab and could result in suspension if violation this rule. Consuming food or drink in lab can pose too many hazards. It will increase the risk of exposure to hazardous materials and potentially attracting pests like cockroaches and rats. Students also are not allowed to pipette by mouth and smell or taste chemicals. Some chemicals with strong odors may cause eyes, nose, or lungs irritation. To ensure the chemistry lab is safe, students should follow all the instructions given by the teacher. Therefore, any techniques regarding to safety rules must need to be practiced. For example, if it's necessary to smell the chemicals, use wafting technique to identify the chemicals. Here is the video on how to use the technique.
In this video, we're going to quickly cover wafting. Wafting is a technique used when you're asked to figure out the odor or the smell of a substance. You never want to place your nose directly above a substance to detect its smell or odor. Continue watching for a quick example of how this is done properly in the science lab.
So in this video, I'll just demonstrate really quickly how to waft vapors so that you can detect the odor of them. So what you're going to do is take a test tube, keep it away from your face, take a deep breath in and hold it, and then you're going to bring the test tube face level about 6 to 9 inches away and waft it towards your nose. You should be able to smell what's inside, but if not, you can move it a little closer to your face if you need to. However, make sure you never put it directly under your nostrils. It could end up damaging your respiratory system. Alright, you're good to go.
Last but not least, properly handle the chemical waste to ensure that there is no harm to our body and other people. Before I end my part, let's take a look at this video on how to handle chemical waste properly.
Organic chemistry experiments involve chemicals that must be handled with care. As evident by the material safety data sheets, the chemicals we use can be hazardous.
Just as it's important to use caution handling the chemicals during the experiment, we must properly dispose of chemicals after finishing the experiment.
Absolutely no waste should be thrown away in the trash.
All liquids, including both reaction products and leftover chemical reagents, should be placed in the appropriately labeled bottle in the fume hood designated for waste collection.
If you obtain too much of a chemical and have excess left over at the end of the experiment, do not return the reagent to the bottle you obtained it from. This excess reagent is contaminated and should be placed in the waste bottle.
Use the attached funnel to pour all liquids into the bottle. Close the top of the funnel after every addition of waste. Do not pour any liquids down the sink.
Solid waste does not go in the trash. Place all solid waste from the experiment into the container labeled for solid waste in the fume hood. This includes the products of your reactions as well as any excess reagents that were not used.
If any glass was broken during the experiment, be sure to carefully discard it in the broken glass container.
Hi, my name is Alisa Diana, and now I will explain about the chemical health hazard and its principal routes of exposure. Before I go into detail about this, I'd like to know what you guys think about hazard, specifically chemical health hazard. If you believe that hazard is the probability that a substance will produce injury under the manner of use, then yes, that is correct, and it shows that you are still on track with your lessons for today. Guys, the possibility that a substance may cause harm is known as the risk of injury. Even very harmful compounds can be utilized safely with good management. Nevertheless, less harmful chemicals can be exceedingly deadly if handled incorrectly. The principal routes of chemical exposure. Before we together dig deep into this, I would like to underline that the usage of hazardous chemicals in the laboratory does not imply that they pose a health risk to you. In fact, the exposure to a chemical is actually a risk. Skin absorption, inhalation, and ingestion are all parts of chemical used to enter the body. The real health risk posed by a chemical is determined by its toxicity and the route of exposure. The toxicity of the substances and the potential entry routes will be used to determine what protective measures should be done. Guys, in general, dermal exposure occurs when a toxicant causes damage to the epidermal tissue or absorbed through the epidermis and enters the bloodstream. Meanwhile, inhalation exposure is about the inhalation of contaminated air through body's airways such as mouth and nose. Then, ingestion, it involves chemicals entering the body through the mouth. Firstly, dermal exposure. Dermal exposure is basically about the absorption of chemical solids, liquids, and gases through the skin and eyes. Then, how fast the skin absorbs the chemical depends largely on the outer layer of the skin called the stratum corneum. The stratum corneum provides a barrier by keeping molecules from passing into and out of the skin. This barrier protects the lower layer of the skin. Thus, how much the skin absorbs the chemical depends on the following factors. First, the place on the skin where the chemical absorbs. Second, physical and chemical properties of the chemical. Third, concentration of the chemical on the skin surface. And lastly, the surface area of the skin that absorbs the chemical. Guys, in fact, chemicals are absorbed more readily through injured or cracked skin. Also, in many cases, skin is a more significant route of exposure than the lung. Why? It is because skin contact with a chemical may produce reaction, such as burn or rash, but it also can result in absorption into the bloodstream with no skin reaction. Absorption into the blood may then allow the chemical to cause toxic effects on the other parts of the body. Next, the effect of dermal exposure. It can cause contact dermatitis, also called eczema. It happens when the skin becomes inflamed from contact with a chemical. Contact dermatitis is the most common form of reported occupational skin disease. Then, dermal exposure can be minimized by switch the harmful chemical to a less harmful substances if possible. Next, we must enforce the wearing of personal protective equipment such as protective gloves, apron, and safety goggles. Lastly, choose the right type of glove based on the type of chemical to be handled. Now, let's get into detail for the most common route of entry for chemical substances, which is through inhalation. Inhalation of chemicals occur by absorption of chemicals via the respiratory tracts. When gases and vapors are inhaled along with oxygen, they can enter the bloodstream, and chemical compounds such as asbestos or silica, for example, can eventually harm the tissues of the respiratory system. Thus, these chemicals can be inhaled in the form of vapors, fumes, mist, aerosol, and also fine dust. As a result, overexposure symptoms may include headache, increased mucus production, and also can cause eye, nose, and throat irritation. Narcotic effects such as confusion, dizziness, or collapse may result from exposure to some chemical substances. If you notice any of these symptoms, get out of the area right away and obtain some adequate ventilation. Chemical exposure via inhalation can be minimized by the proper use of a functioning fume hood for the chemical that produce vapors. Next, use of dust masks and respirators in the laboratory. Finally, make sure chemical containers are tightly closed and that any chemical spill are cleaned up quickly. Chemical exposure through ingestion occurs by absorption of chemicals through the digestive tract. Chemicals can be ingested both directly and indirectly. Accidentally eating or drinking a chemical can result in direct consumption. However, with adequate housekeeping and labeling, this is less likely to occur. Guys, let me give you maybe 5 seconds for you to have an idea about what is indirect ingestion, and do you think that indirect ingestion has a larger chance of exposing you to chemical? Guys, time's up. And yes, indirect ingestion has a larger chance of exposing you to chemical. When food or drink is taken into a chemical laboratory, this can happen. When the meal or drink is ingested, it can absorb chemical pollutants such as vapors in the air, resulting in a chemical exposure. Thus, the unusual taste in the tongue, stomach discomfort, vomiting, and a general sick feeling are all symptoms of chemical exposure through ingestion. However, it can be avoided if all chemical containers are correctly labeled. Then, we should never eat, drink, or chew gum in the laboratories. Finally, we must maintain proper personal hygiene. For example, after working with chemicals, we must completely wash our hands even if gloves are worn. It is to decrease the possibility of cross-contamination. Guys, before I pass this presentation to Husni Hidayah, let's watch this short video about what will happen if we swallow the gallium.
This is gallium. It's shiny and can be turned into a jello-like liquid. You can also play with it without being harmed. But what would happen if you put this metal into your mouth and then swallowed it? How toxic is gallium? How much could you swallow before being affected? And what could it do to your farts? This is What If, and here's what would happen if you swallowed You'd immediately notice the sour metallic taste covering your entire mouth. The melted gallium would be like a thick paste coating your teeth, tongue, and everything else with its silver stain. After you struggle to get it down your throat, it would travel into your stomach. At this point, you'd be wondering why nothing has happened to you yet. Well, that's because in very small quantities, gallium isn't toxic at all. So if you just stopped here with this tiny bit of gallium that you swallowed and put into your system, you'd be fine. But this doesn't mean you should consume gallium, nor do we recommend this at all. And if you ate even more gallium, well, that's when things would start to get dangerous. If you ate more gallium, it would react with your stomach acids, and this would produce gallium trichloride. This chemical compound is lethal to rats, and if you eat enough gallium, it would be lethal to you as well. After eating about 140 grams of gallium, it would react with your stomach acids and produce over 300 grams of gallium trichloride. Not only would it produce this element, but it makes lots of hydrogen gas as well. This could result in some flammable burps, as well as some extra farts. But passing gas would be the least of your worries. As this is happening, you'd also notice some throat irritation, as well as some difficulty breathing. In addition to all this, you'd also notice severe chest pains. And the fumes that it produces might even be more dangerous for you. It would start to create excess fluid in your lungs, and you might not even be able to move, as the fumes could cause paralysis. If you couldn't move, you'd eventually pass out from the fumes and the difficulty breathing. Unless you got immediate medical attention, you would most likely die. But it doesn't have to end up like this. So please, don't eat any gallium. Let's just stick to the fun science experiments and occasionally playing with it in our hands.
Hi, I'm Husni Hidayah. For the next topic, I will talk about steps for establishing a safer chemical storage area. The safe storage of hazardous chemicals is an essential part of laboratory safety. There are regulations, requirements, and best practices that can guide to have a safer chemical storage area. This is necessary to avoid chemical harm to people, property, other substances, or the environment. Before we get into the details, the following are general requirements for safe chemical storage in the laboratory that should be followed. First and foremost, provide a specific storage space for each chemical and ensure retain the chemical there after each use. Chemical must be stored at an appropriate temperature and humidity level. That is why stored chemical must not be exposed to direct sunlight or heat. In addition, storage tray should be used to minimize the spread of spill or rupture occur. All chemicals containers left out of storage areas must be checked at the end of each weekday.
Unneeded item must be returned to chemical storeroom or storeroom. Do not store chemicals on the floor, window, ledges or balconies, even for a while, in order to avoid any potential accident. Apart from that, label container and ensure that they are compatible with the chemical. Shelves should be labeled, stable and secure to the wall or another stable. In addition to safe storage practices, chemicals should always be segregated according to their specific hazards to prevent unintended reactions. As a minimum, laboratories should separate chemicals according to similar hazards, such as flammability, acidity, sensitivity to water or air, and toxicity. For instance, store acid in a dedicated acid cabinet. Nitric acid should be stored alone unless the cabinet provides a separate compartment for nitric acid storage. Store highly toxic chemicals in a dedicated lockable poison cabinet that has been labeled with a highly visible signs. Store volatile and odoriferous chemicals in a ventilated cabinet. Store flammable in a proof flammable liquid storage cabinet. Store water-sensitive chemical in a watertight cabinet in a cool and a dry location, segregated from all other chemicals in the laboratory. Chemical waste is heavily regulated by state and federal laws. Therefore, it must be stored safely and in accordance with the rules before disposal. Fail to do so might have effect your laboratory, community, and the environment. Whether the chemicals are expired, no longer needed, or pose a safety risk in your laboratory, they must be stored properly. So how to store chemical waste properly? Store always in containers that are in good condition and are compatible with their contents. Clearly and permanently label each container as to its content and label as hazardous waste. Store waste in a designated area away from normal laboratory operation and to prevent unauthorized access. Store waste bottle away from sink, floor, and drains. Do not completely fill with bottle. Leave several inches of space at the top of each waste container. Here too, I have attached things that can be done to store chemicals. Do not store chemicals on top of cabinets. Do not store chemical on the floor or in the road area even temporarily. Do not store chemical with food and drink. Chemical can easily get into food if they are near it, so keep them separate and protect your food from contamination. Do not store chemical in personal stuff refrigerators, even temporarily. When storing flammable in refrigerator, use an approved explosion-proof or flammable storage refrigerator only. Do not use benchtop for storage. This workspace should contain only chemicals currently in use for your experiments. Following these simple guidelines will get you well on the way to an efficient, organized, and safely operating laboratory. Spend a few minutes going through the lab with this list on a regular basis, and you should avoid any major incident with chemical storage. As always, safety first. Chemicals can be a very useful tool in doing many day-to-day tasks, especially in chemistry laboratory. However, they do pose risks to health and safety. Before using a chemical product, it's important to know what chemicals are in the product, what are the hazards, what precautions are necessary to use the product safely, what should be done in an emergency. This is why all chemical returns need to label. There are 5 basic elements that should include in labeling of chemical reagents, which are name of the chemical and concentrations, signal words, hazard statement, date of receipt or preparation, and precaution and instruction. All of this information is vital in informing teacher and student about the chemical they use in the laboratory. And for safety, you are not encouraged to use a chemical from an unlabeled container. If the label is missing or unreadable, report it to your lab assistant immediately. First, For name the chemical and concentration, write the full chemical name, spell out the name correctly and completely. If the chemical is in solution, indicate the solution's molarity or strength. Second, signal word used to emphasize hazard and indicate the relative level of severity of the hazard, and also alert the reader to a potential hazard on the label. An example of a signal word that are often used in labeling of a chemical reagents container are danger, warning, and cautions. With that, teacher and student will be aware that the material they are utilizing is hazardous and should be handled with caution. Third, hazard statement. A hazard statement is a standardized GHF phrase assigned to chemical that describe the nature and degree of the hazard associated with that chemical. Every applicable hazard statement from the standard datasheet, also known as SDS, must be included on the container label. For example, causes damage to kidney through prolonged or repeated exposure when absorbed through the skin. The hazard statements are specific to the hazard classification categories, and chemical users should always see the same statement for the same hazard, no matter what the chemical is or who produced it. 4. Date of receipt and preparation. Knowing the date chemical was prepared is very important. Original container should be labeled with the date received and date opened. This is particularly important for peroxide forming compound and other chemicals that become unstable over time, and it is good laboratory practice for all chemicals. Last but not least, precautionary and instruction that describe the required protective measure that must be taken to prevent exposure or minimize adverse effect from exposure to the hazardous chemical. Precautionary statements are directly related to the hazard statement assigned to a chemical class. For example, a hazardous chemical that includes fatal if inhaled as a hazard statement will have do not breathe, dust, fume, gas, mist, vapor, spray as a precautionary statement.
Hi everyone, I am Nurfatin Afrika. I will present the subtopic of potentially hazardous chemical. Let's go. A variety of hazardous chemicals are commonly found in the laboratory. Hazardous chemicals are substances that can cause adverse health effects, as explained by Alisa before. Chemicals exist either as solid, gas, or liquid. No matter its nature of existence, hazardous chemicals will still be harmful to humans and the environment. They are potentially hazardous, especially under high pressure, heat, or when they are mixed with other chemicals. Some commonly used hazardous chemicals in chemistry laboratory are methanol, sulfuric acid, chlorine, and heavy metal, including mercury. The National Fire Protection Association, NFPA, is a global self-funded and non-profit organization which was established in 1896. Their mission is to help save lives and reduce loss with information, knowledge, and passion. The NFPA has introduced color-coded number system called NFPA 704 in 1960. This system is a quick visual guide helpful in drawing attention to the chemical storage and the necessary equipment needed under emergency conditions such as spills, leaks, or fires. The system is displayed as a rotated square shape broken up into 4 subsquares. The material hazard is described within each of the 4 subsquares as the degree of severity. Degree of health hazard, which is the blue box, degree of flammability hazard, which is the red box, degree of instability or reactivity hazard, which is the yellow box, and the white box represents spatial hazard. Flammability hazard is where the flammable materials or substances are able to self-ignite when exposed to water or air, also known as pyrophoric, or which emit flammable gas. A health hazard is a cancer-causing agent such as carcinogen or substance with respiratory, reproductive, or organ toxicity that cause damage over time. Instability or reactivity hazard is when the materials can react very strongly and quickly with water to make a toxic gas. It also will react with itself when it gets shocked, such as by dropping it, or when the temperature or pressure increases. The special hazards are taken from three possibilities. W indicates unusual reactivity with water, OX indicates an oxidizer, and SA indicates an asphyxiant gas such as nitrogen and helium. These are the degree of severity of each type of hazard in the NFPA color-coded system. For flammability, level 0 means that the materials will not burn, and up until level 4, which the materials will completely vaporize at normal pressure and temperature. It also will burn readily. For health hazards, level 0 is for materials that offer no unusual hazards upon exposure to fire conditions, while level 4 shows that the materials can affect health and cause serious injury during a very short period of exposure, even though medical treatment is given. For the yellow box, which is reactivity, level 0 is for materials that are stable even under exposure to fire, while level 4 is for materials that are easily capable of explosive decomposition at normal pressure and temperature. These are examples of the application of an FPA system in the chemistry laboratory. It can be used in chemical storage and also in caution and warning signs, where it can be posted at the entrance to a space where hazardous materials are stored or used. Now, we move on to the next part on how to handle hazardous chemicals. In general, use the appropriate safety and personal protective equipment to minimize all routes of potential exposure. Next, identify and label all materials and work areas where hazardous materials are used. Next, I will explain how to handle hazardous chemicals, which are mercury, ethers, and lead. But before that, please make sure to wear personal protective equipment together with safety glasses and gloves. Review the material safety data sheets, MSDS, and additional chemical information. Identify the location of the nearest eye wash and shower and verify that they are accessible. Lastly, locate and verify that appropriate chemical spill cleanup materials are available. Since many of us didn't enter the chemistry laboratory for quite a long time, let me remind you on how to use the eye wash and shower in the laboratory just in case any emergency happens in future.
And wear goggles for the entire time you are in the lab. Also, never touch your eyes while in the lab, as your hands may be contaminated with a chemical. In the event that a chemical or hazardous liquid does get into your eyes, proceed immediately to the nearest eye wash station. It may be difficult to see, so ask someone for help. Most eye wash stations have a lever or handle to activate the water flow. Activate the water flow and place your eyes directly in the water. You will need to hold your eyelids open and let the water wash your eyes for 15 minutes. It will not be comfortable to hold your eyes open in the water for that long, but it is necessary to flush out the hazardous material, and it is well worth it to save your eyes. Have someone call security and check the SDS for the material that was splashed in your eyes. Ensure that security documents the incident with an incident report afterward. Consult a doctor if any irritation or ill effects remain after 15 minutes of flushing. If a chemical spill occurs over a large portion of the body, it will be necessary to use the safety shower. Move immediately to the shower and begin removing contaminated clothing. If you are in the lab with someone who needs to use the shower, assist them. Let the water flow for 15 minutes.
Mercury can be used to make thermometers, barometers, and other scientific instruments. Mercury is poisonous and can enter the body through the respiratory tract, digestive tract, or directly through the skin. It accumulates in the body, eventually causing severe illness or death. Mercury should be used only in closed system to prevent exposure to vapors. When mercury is handled, especially when transferring it to another container, it should be done closely over a glass or plastic tray to facilitate any cleanup that may be necessary. mercury spills must be cleaned up as thoroughly as possible to reduce the long-term presence of mercury vapors in the preparation area or the laboratory. Now, let's watch a video to get a better understanding on how to handle mercury spills in laboratory.
Shoot! This is the second mercury thermometer I've broken this week. Tim, I need your help. No, please don't walk through there. Just if you could walk around and keep people out of the room, that would be really helpful.
Okay.
I saw EH&S clean this up last week. I think I can handle it, but you know, maybe we'll clean it up. Maybe we'll have to call them, okay? Just if you could put a sign up, that would be great.
I got a broom and a dustpan.
You know, that'll just contaminate the broom and the dustpan, so we're not going to use that. What we need is just some paper right now to pick up the visible mercury. Actually, this jar right here will work perfectly. We're going to scoop the mercury in the glass up with just 2 pieces of paper, and just be careful of the droplets of mercury because they do tend to spread. If you can see here, there's little balls all over the place. And I'm going to take these 2 pieces of paper and...
I am so glad I didn't break this in the incubator. That would have vaporized the mercury too much, and we couldn't have done this ourselves.
I'm finding a couple of the bigger beads, but sometimes the little ones get shoved under the cracks. Yeah, I don't know if it went under there or not. I hope not. But that looks pretty good. You see anything else right here? All right. Now, some people are really afraid of mercury vapors, but this is such a small amount, and we got it contained pretty quickly. I think that we don't have much to worry about in that regard, but we don't want it to be sitting here in the lab for extended periods of time. We just want to make sure we get most of it, if not all of it, up, and if we're not comfortable, we'll call EH&S. You think we did a good job, or should we call EH&S?
Looks good to me.
Looks good to you? You know, it does look pretty good, but since I've never done this before, I think I'd feel more comfortable if EH&S came in.
Next hazardous chemical is ethers. Ethers are a class of organic compounds that mostly contain an ether group where the oxygen atom is bonded to 2 alkyl or aryl groups. The most common types of ethers used in high schools are petroleum ether and diethyl ether, also known as anesthetic ether. Anesthetic ether that has been stored for several years may form crystalline solids called ether peroxides on the inside lid of the container. Once peroxides have formed, this diethyl ether is dangerously explosive. So make sure to handle ethers in the chemical fume hood to prevent exposure to vapors. When handling the chemical, use it away from shock, friction, and open flames. Prevent electric static buildup with a grounding cable. Next, we move on to handling of lead. Lead is a soft, malleable, and corrosion-resistant material. Most of the lead used today is used in the production of lead-acid storage batteries, such as the batteries found in automobiles. Overexposure to lead may cause damage to the reproductive system of both men and women. Effects of the damage include stillbirth, miscarriage, and learning disorder in children whose mothers were exposed to lead during pregnancy. Lead also damages the nervous system, kidneys, blood-forming system, and digestive system, also causing high blood pressure. Lead working areas are clearly labeled with warning signs. Same as while handling mercury and ethers, it is very recommended to put this warning sign. Glove box shall be considered as the primary location for handling lead-based materials in form of powders and solutions. It is mandatory to use a pair of nitrile gloves on top of the black rubber gloves. Hang on guys, the last subtopic for today is the disposal of a hazardous chemical. It is not like you can just dispose them in a regular trash or in the sewer system. And remember to do not dispose them down to the sink. There are 4 characteristics that define waste as hazardous: ignitability, corrosivity, reactivity, and toxicity. In general, to dispose of hazardous chemical waste in the laboratory, it is important to store chemical waste in appropriate containers. Plastic bottles are preferred over glass for storing general hazardous waste. Chemical waste containers must be labeled appropriately with the necessary information. Store waste in a designated area away from normal laboratory operations. Contact the disposal company for your school laboratory to make a schedule to pick up the hazardous chemical waste. Heavy metal waste such as mercury, put mercury waste in a special waste container and label it with mercury waste disposal. Do not mix it with other organic or inorganic waste. Contact professional and licensed hazardous waste firm that will ensure appropriate disposal. It is recommended that the mercury is disposed of within 180 days in accordance with the environmental quality regulations in 2005. Next, we have ethers. Ethers react with air to form shock-sensitive explosive peroxides. For these reasons, it should always be kept in a metal container which will inhibit the formation of peroxides. Ether must never be stored in glass jar. To dispose of small amount of ether, let it evaporate in a fume hood. For large amounts, contact a disposal firm directly. Lastly, for lead waste, transfer it to another container and label it with lead waste disposal. In this case, lab assistants can directly deal with certain recycling companies as they need lead-based products and recycle the lead for use in things like new aprons. But make sure to have a look for a licensed hazardous waste carrier to handle lead waste properly.
In conclusion, all parties should always be careful in the laboratory because its environment is full of dangers and accidents can happen even just because of a small mistake. So remember, safety first.